Good afternoon, everyone. It's my great pleasure to welcome our guest, Dr. P.M. Ravi, to today's session. Dr. P.M. Ravi is the retired head of the Environmental Studies section at the Baba Atomic Research Center. He is currently serving as a visiting professor at Mangalore University and collaboration with International Atomic Energy Agency, Australia. And he is also actively involved in delivering public awareness lectures on radiation, radioactivity, and environmental protection. On behalf of everyone present here, I extend a warm and heartfelt welcome to Dr. P.M. Ravi. Thank you for joining us. Welcome, sir.
Okay. Thank you, Maya. So, I think you are able to hear me. Can you hear me?
Yes, yes.
Okay.
Yes, sir.
Okay. So, first of all, I would like to thank the management of Sripati College of Engineering for giving me a chance to deliver a lecture on the 6-day international faculty development program on next generation engineering education, modern perspectives for education. Specific thanks to the management as well as Professor Praveen Nambishan and all the faculty members of this his group. So, in fact, I should say good afternoon to all of you, in the sense because Professor Praveen told me that there are people from outside also. Hopefully, for all, good afternoon is applicable. So most of them will be in the nearby areas. So I'm extremely happy to see face people like faculty people like you, because my experience is mainly on research, and most of the time I spent in Baba Atomic Research Center. I was working the research area, so my lectureship experience is very limited, first of all. Second thing, I am fully aware that I am facing a crowd at least 30 years younger to me, and who are normally much smarter than me. So they will be, I'm sure you will be very much enthusiastic and will be and I feel there are people from various faculties. So I request all of you to interrupt me in between or whenever you feel like, but the best way will be having a okay. Yeah. So best way will be having a question answer session at the end of the program, or of course, if you feel like, you can interrupt me in between also. So I fully understand the difficulty in attending this type of lecture at 2 o'clock in the afternoon, immediately after lunch, and most of you will be having listening this presentation through your mobile. So I don't know how far it will be effective when it comes to question of seeing the presentation, various slides and etc. So hopefully, please listen at the as early as much as possible. As I was telling, I will be dealing mainly with talking mainly on the chemistry in environmental and biomedical engineering. Why the slides are not moving? Okay. I'll be covering the topics a little in a phase by phase manner. First, I'll be talking about the role of chemistry in engineering, in general application of chemistry in engineering. Then application of chemistry in environmental engineering specifically. In that, I will be covering a little chemistry aspects of ecological cycles, which is very important as far as environmental science is concerned. And then environmental, I'll be just touching upon the environmental impact assessment and pollution transport. of these chemistry aspects of this will be covered. And I'll be just touching upon the chemistry aspects of biomedical engineering. Of course, my knowledge in this biomedical engineering is limited. Yeah. So, ഇത് മാറ്റാൻ പറ്റുമോ? Okay. Sorry for the interruption. It's a little technical issue. So, as I was telling, I'll be discussing a little bit on the application of biomedical engineering, also the chemistry of biomedical engineering. But since I am not an expert in that, I'll not be going much detail into that. Okay. Yeah. Yeah, I don't want my lectures to be like this. See, normally, jokingly, it is told that a lecture is defined as the transfer of study material from professor's notebook to the student's notebook without passing through the minds of both. So this is, of course, it is a jokingly told like that, but we don't want that the lecture to be like that. We want whatever I know should be conveyed to the listener who is attending this lecture. So hopefully it will work out in that manner. See, now, as a faculty, you must have faced a lot of problems, especially when you talk about the engineering students. See, the people who are coming, the students who are coming into this college will be almost just above just completed their +2 and probably qualified for their entrance examination and all. So their knowledge will be just sufficient to pass the examination or just to qualify the entrance test. And they may be, most of them will be unaware of the application of science in engineering, even though they must be using a lot of engineering equipment. They will not be or they are not properly oriented towards the application of science in engineering, whether it is a fan or a car, whatever. So you will be using that. They will be comfortable using all those things, but they may not be aware of the engineering aspects and what is application of science in that. They may not be, and they may also not be aware of the science in day-to-day life. This application of science in day-to-day life, they also may not be very much aware, because we are in our education system, we are all taught to just to pass the examination and not for understanding the things. So many times we think both are different issue. Day-to-day life and sciences are both are different issue. So people, those who are brought up in that sort of environment, the student may not be aware of the application of science in day-to-day life, and they will not be having sufficient knowledge about the interdisciplinary nature of the subject, because nowadays there is nothing like, there is no any fixed partition between various branches of science, say physics, chemistry, mathematics. There is physical chemistry is there, chemical physics is there, biophysics is there, biomathematics is there, biostatistics is there. So they are all interdisciplinary. Especially when you come to the engineering side, you will have to apply most of the branches of science And if you want further innovative thing, you will have to mix all this in a proper way. And there is a lot of misinformation through the public domain, mainly because of the scientific, non-scientific and all. So we don't know, the student is not at all familiar which is the correct one and which is the wrong one. And of course, there will be parental pressure and peer pressure to excel in the marks and excel in the social status and all those things. And since we are all brought up in a very, say, hierarchical form of society, especially the students are all brought up in a hierarchical form of the society, they will not be in a position to understand what their skills are. They will, many times, they will not be asked, they will not be given an opportunity to commit the mistakes. So in a science education, most important thing is you have to allow the student to commit the mistake, then only he will learn from the mistake. So this is very, very important. But people will not be given that chance to commit mistake and learn from the mistake. So they are not fully aware which field they are good and which field they have inherent ability. Those information are not available with them. And of course, in addition to that, the people will have generally very high ambition to secure high profile jobs, high salary and high positions in the society. But for that, you need the application of science. So now faculty, now when they come to the college, you people have to mentor them as a faculty, to mentor them. So you should be highly knowledgeable in academics and should be very enthusiastic in using knowledge to solve day-to-day problems, and highly skilled in application of science and engineering. They, as an engineering faculty, you should have the capacity. So most of them will be having that capacity, and it is always expected that once you pass out, the students should have a employability. That means he is not only good in his theoretical aspect, but he is able to apply the knowledge in industrial status. So he should be able to do that. That sort of capability should be given to them during this course of engineering work. And they should also have good societal and emotional intelligence to deal with the public and all those things. And they should have good awareness about their own health, about nutrition, as the hygienic aspects and all those things. They should be very clear. These are all very much important for a holistic development of the student. So in addition to that, you should cultivate the personal attributes like civic sense, confidence, self-respect, cooperation, and maintain the ambitious, which already they have once they join there, and should be guided. You should guide them properly in that. So it's a very responsible job. And when it comes to the additional issue of artificial intelligence, you have more complications, like see the continuous use or inadvertent use of the AI, artificial intelligence, like Gemini, ChatGPT, all those things. People have they are not using their own critical thinking. Most of the answer they are taking from these domains, the AI domains. So which will reduce their critical thinking. They think that it's not needed. Critical thinking is not needed. So unless you use it, it will not be properly you will not be able to culture or strengthen your critical thinking. And also this is followed by the poor problem solving skill. Again, you give the question to the ChatGPT, it will give some answer. So you will not use your own skill to solve the problem, and probably blindly trust the AI. You don't see the authenticity of the answer provided by the AI platforms. So this also will have a problem. And of course, there are another issues like ethical issues, like the plagiarism of copying of the information, and then bias. You will be more biased towards the answer given by the AI platforms. And of course, there is a question of a very important concern on the data privacy. So these are all very important. But of course, you cannot get away from the application of artificial intelligence. It is going to stay here with us. And definitely it is a very useful method, a tool for improving your research capability, your thinking capability, everything, if it is properly, responsibly used. So artificial intelligence is essential part of our life. And in the near future, you will have robots taking the class. All issues will come in the near future. And there is a need for interdisciplinary learning. And you should have the focus on problem solving and innovation. People think about how you solve the problem. It is not that you know so many things. So how you apply your knowledge to solve your problem. So we expect this faculty has the responsibility to produce the students and who are going to be tomorrow's innovators. In that context, I feel the faculty development program is very nicely engineered and performed well. And I'm sure this will be very useful in enhance the faculty knowledge in interdisciplinary areas, including science, artificial intelligence, and emerging technologies. This will also is expected to improve teaching methodologies using innovative and outcome-based approaches, and will develop skills in integrating the digital tools and artificial intelligence into teaching learning process. It will also be strengthening the understanding the student psychology. Yes, it is very important. Student psychology is very important. Every student is different. So psychology is very important. And especially you have tools in artificial intelligence to give personal attention to every student depending upon the knowledge level, skill level, etc. So this will be very useful. This type of the training to the faculty will be very useful for developing a good academic platform in the various institutions. And then mentoring, and of course the counseling, all those things. So, and promote awareness of health, wellness, and current trends in education and entrepreneurship. Yes, finally, what is going to, not only in the near future, but after 30 years, because this is an era where the technology is moving faster, much faster. In our terms, it was comparatively slow. We could catch up with the development of the technology, but nowadays you have to be very, very, very fast, and you should be updating your knowledge very, very frequently. So here today I will be talking a little about the chemistry in engineering in general, and also a little more specific on environmental engineering and biomedical engineering. So always we say chemistry, jokingly people say chemistry has engineering solves the problem, but chemistry has a lot of solutions. They have solution, nitric acid, sulfuric acid, all those things. But the actual solution means also solving the problem should be done by the engineer. Now, let us look at the big factory, that is the nature itself. See, the whole earth is managed by the chemistry of 92 elements, right from hydrogen to uranium, which are known as naturally occurring elements. And you have a lot of what you are doing is the whole life system, river, sea, fishes, air, soil, whatever you say, these are all done by only 92 elements. And you can think of the skill, the chemistry involved in this type of system, the maintaining the whole factory, that living system. And it is very interesting to note that the whole living system is made by hardly 22 elements, from the hydrogen to few elements in the first one or two or three periods. These elements are mainly used in the sustaining the living system. And chemistry is the central science for any industry, because it explains the materials and reactions. So if you have any reactants, if you have a raw material, you want a product. So it can be either a physical reaction or it can be a chemical reaction. If it is a chemical reaction, you should know what is the chemistry involved in that: kinetics, free energy, enthalpy, all those stoichiometry, all those information is needed if you have to produce a quality product. Then for every industry has different requirements. Say, for example, an industry dealing with acid, nitric acid, you need a non-corrosive material to hold the thing, hold the tanks, pipelines, and then if you want higher temperature, higher pressure, for all those things, you need specific material. So this specific material has to be developed by the various chemical reactions. So chemistry is very much involved in, right from plastic to different types of steel, and then many types of other materials. So for example, in a nuclear reactor, you need material which can withstand very high radiation field, very high temperature. The temperature goes up to about 1000 degrees Celsius. So a very high temperature is and very high pressure, and a lot of water and a lot of acid involved in that corrosive system. So in such cases, you need to have the good material developed, which requires the application of chemistry. Now let us take a very simple example. You must have all heard that the India is very rich in thorium, monazite. See, if you take the east coast, part of the western coast and eastern coast of India, including our Kollam, Karunagapalli, this Kanyakumari and all those things, and right from this area to this Manavala Kuruchi of Tamil Nadu, then you have Orissa. In this area, there is a very large deposits of thorium, we can say monazite, and this monazite is very much rich in rare earths. And what for these rare earths is used? Rare earth has application in almost all new things. If you take the mobile, you are using a lot of rare earth elements in that. And a very typical example is the battery for the electrical vehicles, because the electrical vehicle battery has needed a lot of large power, and it should produce a strong magnet, and it should also withstand very high temperature, because the temperature goes up very high in normal materials. The magnetic flux, magnetic strength reduces as the increase in temperature. But this in this case, if you use the combination of the ND, that is neodymium, and praseodymium along with iron, if you use this combination to produce the magnet, it has all these properties. So it is very commonly used in most of the, not most of the, all of the electrical vehicles. So this is going to be very high, and India is rich in that. India probably only second to China, but only problem here is the chemistry, because see, you have a lot of monazite which is in a very raw sand, and from that you have to separate this ND and PR in very high purity. That is, normally we call it as 5N purity. What do you mean by 5N purity? 99.999. That much purity should be there. Then only one can use it in the magnet. So this involves a lot of separation, physical separation, magnetic separation, gravity separation, and then chemical separation. A lot of acids, solvent extraction, ion exchange, all those methods are to be used in a very high precise manner. So chemistry plays a very important role. And I must say that India is yet to pick up, though we have a lot of work in this, a lot of scope in this area. We are yet to reach the level of China. The 95% of the magnet is supplied by China now, though we also have enough deposits of monazite as comparable with the China, but we are not able to produce this 99.999 level of magnet. So I think when you go to your students, you will have to motivate those students to make them aware of this type of challenges, so that they will also understand what are the things required. And so for that purpose only I mentioned this. And another way, simple issue. So we see a lot of mangoes here, and it goes just unused, partly misused, decayed, all those things. But if you could make into a quality product, like it will have a lot of this one. See, here also involves a lot of effort to purify all those things. So I think it will be, these are some of the day-to-day problems which students should be aware, so that how they should know how one can use the science for the development purpose, for social development or engineering purposes. So probably you can think of giving a project to one of your management students to prepare a feasibility study for the above project. So how to convert the lot of magnets, mangoes available in this area into a useful product. See, and chemistry has a lot of application in environmental impact assessment. If you take the case of emission from a plant, see, it can be nitric oxide or sulfur dioxide or anything. So in order to understand how it impacts the public, you should know how it is getting distributed. Once it is released into the air, how it is distributed into the air, how it is going to deposit in the plant surfaces or earth, and how the plants pick up those, and how the animals inhalation, ingestion, all those things. So one should know what type of what should be whether it is whatever is released from plant, its physical nature should be known, whether it is a particulate, whether it is a vapor, or this is a gas. This information should be available. And the chemistry of it's when it interacts with water, what happened to NO. Say for example, NOx, when reacted with water, it will form the nitrous acid. So, or SO2, when it is dissolved, it forms sulfuric acid. That sort of information should be available. And not only that, kinetics of that, and equilibrium constant, all this information, reaction stoichiometry, this information should be available. So not most of the time you must have seen this when it is when it is going from the chimney, it follows a conical path. It is basically because of the double, we call it as a double Gaussian distribution model. The plume will be distributed in a vertical direction as well as horizontal direction, and it takes up a conical this one, and once it reaches to the ground, it gets diluted like anything. So in order to understand this, you should have equations to be developed, and in order to understand the equation, you should understand the chemistry behind that, and this is very important in the environmental cycles. And in addition to that, it is very important to know the whole life is sustained by natural cycles like nitrogen cycle, carbon cycle, water cycle, etc. So we should understand how does it work and what are the chemistry involved in this work, in these processes, natural processes. And of course, this is in the environmental side, and biomedical engineering also. There is a lot of application of industry chemistry in applying or developing a drug delivery system, the cover for the various medicines, which selectively open up depending upon the pH conditions or something like that. So you can think of a tablet which supplies which supplies the medicine to the stomach whenever there is a pH, it decreases less than 4. Something like that. If that sort of a accurate delivery of medicines to the human body, this will reduce the side effects and all those things. And of course, it will be very useful in development of biomaterials. For example, implants and all, you may use titanium because it has to withstand the atmosphere in the body, human body, and it should survive for a long period because most of the implants are there lifelong. So it should have that chemical environment, it should be able to withstand that chemical environment. So the development of such materials involves a lot of chemistry. And of course, diagnostics in X-rays, MRI, all those things, you are using the chemical information for producing various medicines and all those things. This is about in general about the application of chemistry in industry, and we need people very innovators for this industry. So if you are taught accordingly, then there is a good chance of their becoming this one, and we'll have good students like highly employable, and they may become entrepreneurs, and they should understand the chemistry in the core engineering, and the application of the artificial intelligence will be very useful in say for example in literature studies like that, and also in simulations. If you have some idea, you can simulate that idea and get the result, and whether it will reach that level of your quality that can be tested before carrying out any laboratory experiment. So, and of course, one has to think even beyond artificial intelligence also. Probably one of the good model beyond artificial intelligence is the nature's this thing itself. So before going into the next phase of my lecture, if anybody has any question so far, I can answer. Hello. Okay. Hello. 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 Oh, okay. Hello. Okay. Thank you. Once again, sorry for the interruption. It all because of some technical issue. It's very normal when we talk about when you deal with this this online thing. This will be very normal because um, technical issues comes frequently. So what we were discussing is about the um, environmental science, and environmental science integrates natural science and so other social sciences with like environmental ethics, environmental impact assessment and planning, etc. The environmental science and engineering has emerged as a multidisciplinary field of study to access the impact of interaction of living beings and micro environments in which we live. So this has attained a very important, very position in the near future. Oh. Yeah. The understanding the science behind the interaction between various components in the environment. See, the whole environment is can be divided into, say, you can say biotic and abiotic. And the biotic component is includes our all these plants, animals, and other living things. Has a lot of biodiversity and all those things. Several types of plants, several types of animals, bacteria, fungus, so many things. And it is all it produce the abiotic components like air, water, and soil. They support the living by providing the required nutrition, required air for breathing, water for drinking, food for eating, all those things. They are supported by the. So it is very important to understand the chemistry behind all those possible, but it is a very complex issue. So I will be discussing only a very small part of the whole thing. So we should also the engineering should also apply the application of science in solve the environmental issues like dealing with the pollution control, water purification, and whatnot, that sort of things. Again, we have the periodic table with us, and again, as I was telling, the living system uses only about 22 elements, and the human system, it's interesting to note that 99% of the human body consists of only 6 main elements like oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus. All our body system is managed by this small group of elements. And when the nature uses the organic chemistry, that is make use of the carbon-carbon bonding between the carbon bonds, while artificial intelligence uses mainly silicon, the silicon bonding. So we can normally, it can be told that natural intelligence is mainly by carbon-carbon bonding, while artificial intelligence is mainly by um, um, the silicon binding. So let us go into a little deep into the our 1 minute. Excuse me. ഈ വരയൊക്കെ എങ്ങനെ വന്നു? അതും പോണമെന്നില്ല. ഇത് ഉണ്ടല്ല, അല്ല ഇതിങ്ങനെ ഇങ്ങനെ Okay, I think it's so. We should understand the basic chemistry behind the natural cycles which sustains our life. That is carbon cycle, nitrogen cycle, and water cycle. I'm sorry, there is some lines are coming in between. You should, I can't do anything because with my limited knowledge of this one, I cannot do much. But I think it is not going to affect your the presentation as such. So let us continue with that. Why nitrogen is required for our human life? We all need proteins. Protein is very important for our sustenance of the life, and we are taking about 10 to 15 gram of protein per day. And where from it comes? The nature has stored about in the air. Nature has stored about 78% of the air is nitrogen, and this nitrogen alone, but it is not in a protein form. It is a nitrogen N2. N2 for a chemist, N2 is a very inert gas, highly unreactive, and of course, so you have to convert them to the way that can be used by the this. How they do that? See, there is a nitrogen cycle which sustains this type of Yeah. Once again, sorry for the interruption. So we'll continue with the slide movie and just a minute. Unmute ആണ് ഇത് വരുന്നില്ലല്ലോ ഇപ്പോൾ വരുന്നുണ്ട് അത് അവിടെ ക്ലിക്ക് ചെയ്യാനായിട്ടാണ് ഓക്കെ താങ്ക് യു So as I was telling, the nitrogen is about 10 to 15 gram per day of nitrogen is required for as protein for human body. So there is a major cycle, that is how you convert this nitrogen into edible protein. So nature has done first it is oxidizing into nitric oxide by the lightning, because normal nitrogen and oxygen will not react, because the elemental nitrogen is very stable, and oxygen also is stable in the environment at atmosphere. So you need some very high temperature for this reaction to take place, or from the chemistry point of view, what you need is this is a high activation energy is required for this reaction to take place. So this if you use the Arrhenius equation, you can calculate how much if the activation energy is known, how much temperature is required for this reaction to take place. So this because of the very strong nitrogen to nitrogen triple bond in nitrogen and oxygen to oxygen double bond in oxygen, they are inherently stable. But when you bring them to very high temperature, like the lightning, so in that condition, the oxygen reaction takes place, nitric oxide is formed, and this nitric oxide dissolves in water, and this will be going into the soil as you can say dissolved nitrous acid or nitric acid, like that. So then what will happen? The nitrates also is not useful for human being, though it is very well useful for plants. So the plants, what they do, they convert this bacteria with the help of bacteria. The soil convert this into nitrates, which is taken up by the plants. And very interesting chemistry comes when the conversion of inorganic nitrogen. So far it was nitrate, which is in the inorganic form, and you have to convert it into proteins like the organic form. So how it does that? This takes place inside the plant cell, and you can see that the first thing is to conversion of the nitrate into ammonia. And this ammonia, you can see that if you, from chemistry point of view, the nitrate in nitrate, the valency of nitrogen is about +5, and the ammonia, the valency of nitrogen is -3. That means you are reducing the nitrogen into very reduced state. So you need a lot of hydrogen, and for this to take place, and you need a lot of energy, and you need a lot of the presence of catalyst. Normally, if you simply keep nitrate in water, this reaction will not take place. So nature has its own way of doing this. How it does? It converts with the help of sunlight, the photolysis of water takes place, and you will get a lot of the hydrogen gets split into H plus, and a lot of electrons will be produced, and this H plus with the help of NADPH, which is a organic compound which is used in the which is already present in the protoplasm of the cell, and with the help of this catalyst, this reaction takes place, and the nitrates gets converted to ammonia and then further into amino acid. So you can think about this complex chemistry which is involved in this the nitrogen cycle. So from the chemical engineer or environmental engineer's point of view, a lot of lessons can be learned from the this one. See, nitrogen is abundant but not suitable for eating. Nature converts it into products suitable for all living beings and energy efficient. It's a reversible process. You can see the closed loop. There is no any waste produced. So the whole thing is converted back to the this one. So very good feedback mechanism, because whatever is needed only will be produced. So all this lightning, rain, bacteria, protoplasm in the cells of the plant, all this make use of complex chemistry and converts into the required form. So it will be very interesting. Similarly, if you take the case of carbon cycle, is also same, more or less same way only. The carbon dioxide, it takes part in the it will be absorbed by the plant, and it forms photosynthesis, and again photosynthesis also. Here the major source of energy is nothing but sunlight. The visible region of the electromagnetic spectrum will be used by the plants to carry out the photolysis, and of course there are other catalysts like magnesium and all those things taking place, and then it converts into the glucose, the carbon, and in coordination with the nitrogen cycle, it will incorporate proteins also in this food items, and this chemistry is performed by the nature. So if any variation comes in this, if the concentration in the natural level changes, then it is called a pollution. And because of the advent of industrial revolution, because of large industry, we are aware that the carbon dioxide level has increased like anything, much higher than the normal level. So this has started affecting the our earth, especially mainly because of the global warming, because carbon dioxide has the capacity to absorb heat, hold the heat in the earth, which increases the global warming, and the greenhouse effect of the carbon dioxide is very this one. So an environmental engineer should be aware of this type of issues, and so that he can develop suitable methods for combating the pollution or the impact caused by the this one. So maybe for a student, he will be very much interested to know that, or rather, you can give us project something like that. See, during which season the soil in Kerala is likely to be rich in nitrate. This type of, because it all needs a thought-provoking questions. You have to think about the lightning, when the lightning is happening, when it is getting converted to oxides, and then when the which carries down the rainwater carries down, and whether that bacteria is present during that time, because bacteria is very sensitive to temperature and pressure, temperature and humidity and all those things. So this type of projects to the students will be thought-provoking, and most likely this will not be, you will not get an answer for this in even the artificial intelligence platforms. If it is of course you can split it into different questions, small questions, and ask ChatGPT. You may get the answer for that. So, but that will give a training for the student how to use ChatGPT or Gemini or Copilot in a responsible way to get the answer and also to solve the problems. So this type of the initiative from the faculty will be very useful for developing innovators in your institution. So like, during which season soil in Kerala is likely to be, these are doesn't have a very yes or no question. These are not yes or no question, and you don't have a fixed answer. So these are, this gives a this will provoke thinking among the students. So like, can we produce the oxidation of nitrogen in the laboratory? Like, if you simply put nitrogen and oxygen in a jar, will that reaction take place? And if you want, what I should do, and how much energy is required for that? What is the source of energy? This type of question can be thought of asking to the students, or students can be given some training to answer this type of questions. So, or can we produce conversion of nitrate to protein in a laboratory? Is it possible? If at all it is possible, how much feasible it is? What is the economics involved in that? This type of multidisciplinary questions will be helpful in understanding the nature's wonder. And similarly, the natural water cycle. Water cycle gives you the water, purified water for all of us for drinking. And what it does, it takes water from the sea, evaporates, and you have to use the heat of enthalpy. You convert into vapor. How much energy is required? 540 kilocalories per gram, and all those things, kg, and all those things you have. Then it is going to this land. It is getting condensed, and but the condensation, how much some heat is released? Who takes up that heat? How the heat is spread while the this thing takes place, and how precipitation happens, the nucleation, the catalysts in the dust particles, which acts as a nucleation agent, and it coagulate the vapor, water vapor, into droplet form. So this is the science involved in that. Should be very much interesting. And then for an environmental or for an engineer, this is a very a water purifying system, a natural water purifying system. No pipeline, no energy required. It's a continuous process. Whenever the whole thing happens naturally. So it's a wonderful engineering pattern. So there are a lot of lessons to be learned from this natural cycles. So you have evaporation, heat and mass transfer process is there, condensation is taking place, heat release process is taking place, precipitation, that is nucleation, and then transport process. Here the diffusion and convection. The mass transport is taking place, and the diffusion is also taking place. And when it's passed through the soil, there's passing through the porous media like ion exchange and all those things. And finally, mass balance. Finally, there is water is not created or anybody. It is already using the same water, so it is the whole thing is balanced. So closed loop mechanism, phase changes, and similar to process industries, and large scale resource management, and inherent purification system provides purified water throughout the earth. No motor, no pipeline. Provides purified water, so again, in order to provoke more interest, students can be asked this type of questions, like use this concept for whether can we use the desalination of seawater by using the same technique. Presently, it is normally commercially desalination is carried out, but normally these RO process, that reverse osmosis process, is used. But can we use this for this type of heating methods? And if at all possible, what is the flow diagram? What is the energy required? What is economics involved in that? And also pollution control. If the water is contaminated with the pollutants like heavy metals or nitrates or whatever, then can we take water, purify that water using this the solar evaporation pond? In many of the power plant, nuclear power plant, for example, in Rajasthan, the water is purified by solid waste is purified by the solar evaporation ponds are used. But they're also, they are not using, it is not being used for purification of the water. So now this is all about the environmental transport and environmental engineering. And then I'll just touch upon the role of chemistry in the biomedical engineering. As I was telling, I'm not an expert in that area, but still I can just throw some information. Like as I was telling, it is much useful in a drug delivery system, development of biomaterials, and diagnostic scanning, like that. So especially when you talk about the we are all familiar with X-ray and CT scan, and how does it work? In CT, the X-rays, what you need, what is happening is the electron-rich material will absorb more X-rays. You know, X-rays is a part of the electromagnetic radiation in the with a very high energy and low wavelength, next to only gamma rays. So it's a very strong interaction, and they interact with electrons, and wherever the electron density is very high, like if heavy high atomic number materials are there, then it will be absorbed. That's why in bone and all, bone tissues and all, it will absorb because it contains calcium and all those things. So phosphorus, calcium, so they will absorb as compared to the carbon, hydrogen, which is there in the tissues. So you get a black image because of the and CT scan again, you like in a photograph, you need a contrast. Black is used as a contrast because black absorbs the light. So here, there are contrasting material like iodine and barium, which absorbs large amount of X-rays. So you get a good contrast, so that picture clarity will be there. And as MRI is very much commonly used for identifying the cancerous tissue and all those things. So there also the hydrogen nuclei, the magnetic effect of hydrogen nuclei will be used. So highly magnetic material like gadolinium, etc., will help in increasing the contrast. So it will be very useful in that. These are all developed based on this our chemistry information. And PET scanning, you know, see, the more you go, see, X-ray can detect only a very vague picture of a human body, like bone and all those things. So if you want to go for MRI, means you are very close to hydrogen. You can even count the hydrogen in that. So you are getting more clear information about that. This one. And the PET scan is uses the FDG, that is F18 radioactive material, where it is a it produces proton, and this positron is produced, and this positron is annihilates with electrons in the human tissue, and then it can even count even small electrons in that, so that the cancerous cell can be easily detected. So these are also again biomedical science. Also there is a good application of engineering. I think I have almost completed my this one. Some of the closing thought will be like this. Chemistry plays a very important role in general and in environmental and biomedical engineering. Of course, it plays big role in many other engineering field also. So the limited time, I have to compare these areas. And engineer of the future should be definitely a system thinker and interdisciplinary and ethically grounded, very much important in the future. And one should be able to think beyond artificial intelligence also. And for that, probably some of the prototypes are available in the nature itself. So always the natural intelligence is always much better than artificial intelligence. So far, if you want to go beyond artificial intelligence, beyond ChatGPT, beyond Gemini, then you have to look into the engineering wonders of nature. So this is what I wanted to say. And if this lecture has had a good reaction, then we have a good chemistry between us. If not, we need a lot of, this is an endothermic reaction. I need a lot more energy to make, to convey my idea. So anyway, thank you for your kind attention. So if you have any questions, I'll be happy to answer I know the answer.
Participants, if you have any questions regarding this session, you may ask, please.
No. Okay, thank you for that kind attention. And if you have any questions later also, I think the presentation will be shared to all of you. And my email ID is there, my phone number is there. So feel free to call me. I'll be happy to answer. Once again, thank you.
Thank you, sir. On behalf of all participants, I extend our sincere gratitude to Dr. PM Ravi for delivering an insightful and enriching session on chemistry in environmental and biomedical engineering. Your vast experience, practical insights, and clear explanations have provided us with deeper understanding of the role of chemistry in addressing environmental and biomedical challenges. The knowledge and perspectives you shared today will undoubtedly benefit all the participants in their academic and professional journeys. Thank you once again, sir, for your valuable time, expertise, and inspiring interaction. We are truly grateful for your contribution to this FDP. Thank you, sir.
Thank you. Thank you very much.
So let's wind up the session.